Right triangles like this one are one of the most important shapes in geometry. And this triangle is the foundation of one of the most important theorems in mathematics called the Pythagorean theorem. The Pythagorean theorem didn't actually start with Pythagoras. It actually started with the Babylonians and the Egyptians who used this to build things like these pyramids here. And they had a really amazing technique that they used to build these wonders of the world here. And we have some evidence that they used ropes to make right triangles, specifically 3, 4, 5 right triangles to make perfect right angles. So Pythagoras came along a while later. He was about 500 BC, and the Pythagoreans were geometers. The geometry that they studied was the foundation for everything that they did in mathematics. They didn't do a lot of algebra, they did a lot of geometry. And so they took this triangle here and they studied the squares. If they put a square on the bottom here and the square on this side, and then a square on the hypotenuse here, and they said, what is the relationship between those squares? And they found out that the two smaller squares have an area that adds up to the area of the large square. And that was the key to opening up a lot of applications and discoveries that could be made with the Pythagorean theorem. These two squares, the a squared and the b squared, equal the c squared in area. And so now we can take that on to algebra, which leads us into calculus and lots of amazing tools and things that we can develop with the Pythagorean theorem. Let's look into that. So the Pythagorean theorem really was a geometry theorem. We're talking about these areas of these two small squares of this right triangle add up to the area of the square on the hypotenuse. So that's the original form of the Pythagorean theorem. Says the area of the squares of the two small sides, the legs. By the way, these are called legs. That's important. We have legs, two legs, the two sides that make the right angle. And then we have this side, which has a fun name, the hypotenuse. Hypotenuse. All right. So the hypotenuse is that third side that's opposite of the right angle. Okay. And so we usually call that hypotenuse C and A and B for the shorter ones there. And we come up with this theorem here, this equation that tells us a squared plus b squared has to equal c squared. So the squares on the legs have to add up to the square on the hypotenuse. So let's check out some examples here. All right. So first one we want to see are these right triangles? Okay. And so we know that we just saw that the Pythagorean theorem says that if they're right triangles, then the squares on the legs, not a very good square, the area of the square on the legs would have to add up to the area of the square on the hypotenuse. Okay? So what does that mean? That means that this area of this square, which is 3 squared, plus the area of the square on the 4 times 4 is the area of that square, would have to equal 5 squared. Is that true? Well, we don't know yet. We're just checking it out. So sometimes we'll put a question mark there. We don't know. Well, let's see. Is 9 plus 16, 4 squared is 16, 5 squared is 25. Is that true? That sure is. 9 plus 16 is 25. And so 25 equals 25. Yep. So yes, this is a right triangle. Okay. Well, what if it was 9, 15, and 13? Well, let's check that out. So we have the square on the legs is 9 squared. So remember the legs, the two sides that make the right angle.
is the sum of the square of the legs equal to the square of the hypotenuse. So this is our A, this is our B, this is our C. 9 times 9 is 81. 13 squared is 169. And 15 squared is 225. Again, we should probably put a little question mark here. We don't know. We don't know if it's equal. Let's find out. Well, 81 plus 169 is 200, and, well, 60 and 80 is 40. Be 140. This would be 250. Is 250 equal to 225? No, it is not. So this is not a right triangle. All right, so we can use the Pythagorean theorem to check to see if it's a right triangle like that. All right. And then if we have a missing side, we can use the Pythagorean theorem to find that missing side. Let's see how that works. Well, the Pythagorean theorem says the square of the legs, remember, the legs make the right triangle. The hypotenuse is always opposite, okay, of the right angle. So to find the missing side here, we could say, well, 3 squared plus 4 squared equals x squared. So that's 9 plus 16 is equal to x squared. We're just doing algebra now. 25 equals x squared. What's the opposite of squaring? Well, that's square root. So 5 equals x. All right? So we can find the missing side using the Pythagorean theorem. Remember, the hypotenuse is always the C spot, goes in the C spot. A squared plus B squared equals C squared. Probably one of the most important equations in all of mathematics. All right, so how about this? Little application problem. Your school is 4 miles east of an apartment. East would be left. So let's say your apartment here is in the center of the axis here of this graph, in the origin, okay? So if we go 4 miles east, that's 1, 2, 3, 4. That's right over here. So that is your school that is 4 miles east of your apartment. Okay. And what do we say? A recycling center where your class is going for a field trip is 4 miles south of your apartment. So here's your apartment. Let's go 4 miles south. 1, 2, 3. We're kind of off my graph here. All right. So there's 4 miles. So this would be south. This would be -4 on the graph. This would be +4. And that's the recycling center. Okay, the question is estimate the distance between the recycling center and your school. All right, so what we have here is we've got a right triangle because we're going to travel from the school to the recycling center. Okay, we don't know that distance. This is 4, this is 4, but we don't know that hypotenuse, C. Well, the Pythagorean theorem says a squared plus b squared equals c squared. A and b are the legs, 4. And so this is going to be 16. And this would be 32. And we're going to square root this thing. Now, how do we square root that? Well, we're going to need a calculator here. So using Desmos Scientific, you can find that online. It's desmos.com/scientific. It's a good way to go. Or any scientific calculator will work. The square root of 32 is a decimal. It's not a whole number. So it's going to be 5.65, so on and so forth. Let's round this to 1/10, 1 digit after the decimal point. So that would be 5 points. Remember when we round, we're cutting off a 5. And if this number that we cut off is 5 or bigger, we round up. So this will be 5.7. All right. So 5.7 is approximately what it is. So 5.7, and that's approximate. We'll use a little squiggly equal sign, which means approximate. And this is miles. Okay. So that makes us real useful in coordinate geometry, and a guy named René Descartes is responsible for this idea of graphing points in the coordinate plane. And when we generalize this, we get something called the distance formula. We're not going to use this a lot right now, but we might see it down the road. So the distance formula is just a generalization of the Pythagorean theorem with an a squared and a b squared and a c squared. Okay? Really useful for finding lengths in the coordinate plane. And we'll use more of that as we go. All right, so let's practice a couple more. This might be, well, let's do one, and then you might pause it and try F on your own. So here we're missing a leg. So we've got x squared plus 8 squared equals 10 squared, because this is our A, B, and C. And so we know what 8 squared is. That's 64. We know 10 squared is 100. Now we're just doing algebra. Remember, what you do to one side, you got to do to the other. Let's get the 64 out of there. We'll subtract x squared. 100 minus 64 is 36. And then we'll square root, and x is a square root of 36. We just go in the positive version here, is 6. Okay, and that's how it's done. So maybe pause and try this out. Now, by the way, one more thing I'll say here about these is this ends up being, whoops, it was 6, right? 6 was the answer there. Notice these are all whole numbers. They don't always have to be whole numbers, but here they were, and this is what we call a Pythagorean triple. A Pythagorean triple means that all the sides are whole numbers. Okay? So Pythagorean triple is like 3, 4, and 5. That makes a right triangle. Or 6, 8, and 10. Okay. Well, try pausing the video and try this one out, and then come back and check it. So let's check it. See if what we get. We got a missing side. Now this is the leg. Remember, legs go in the a squared plus b squared side. All right, they go by themselves. This is a squared plus b squared equals c squared. All right, so x squared equals 140. Oops, sorry, not equals. Plus 144 equals 169. Subtract 144, and we get 25. Now, square root both sides, and x is 5. Again, we get another Pythagorean triple. Doesn't always have to be a whole number. Sometimes it'll be a decimal. All right, so that's the idea there. That's the Pythagorean theorem. Again, one of the most important equations in all of mathematics. So super important. We'll use it all the time. Keep practicing it. Every time we have a right triangle, that's the key, a right triangle, we know that a squared plus b squared equals c squared.